Hello, welcome back to Learn Economia. Today we are going to discuss a very important model of economic growth, that is Meade model of economic growth. So let's see what is it all about. Moving on to the model, this model is being given by a British economist, James Edward Meade, or we call this person as J.E. Meade. This person has received the prestigious Nobel Prize in Economic Sciences in the year 1977, and he has written a famous book, Neoclassical Theory of Economic Growth, and it was published in the year 1960. Apart from this book, he has written many other books as well, which discuss various aspects of economics. In this session, we will be focusing on the neoclassical theory of economic growth given by James Edward Meade. So let's focus on to the same here. This model explains the role of three elements, that is population growth, capital accumulation, and technological progress in determining national income of a country. So Meade tells that the income of a nation is influenced by population growth in the nation, then capital accumulation, and also technology in the economy, the progress of technology in the economy. So we will see how these happen in the economy and how Meade was progressing with his explanation of economic growth. So he was using a production function here. This is a production function that Meade was using. And in this production function, we could find that y is equal to f of k, l, n, and t. So here this y stands for the net national output in the economy, or else we could find that this is the net national income in the economy. This k is the stock of machines, or we could say that this is the capital in the economy. And coming to L stands for labor force in the economy, the number of people who are in the labor. So this is what is meant by L. And N, this means the land availability in the economy. And this land is assumed to be constant for the time being. We cannot increase the size of land. So it's assumed to be fixed. And T here stands for technical progress. Since land or N is fixed here, we could find that the production function that Meade was using, the modified production function that Meade was using, is equal to y as a function of k, l, and t, that is capital, labor, and technology. So let's proceed with the model. Here, we have already said that the production function that Meade was using, the modified production function, was y is equal to function of k, l, and t, right? Here, you need to bring about changes here. So what will be the change in income? Change in income is indicated by delta y. Delta y is equal to V times delta k plus W times delta L plus delta y dash. So how would you be explaining this equation? In this equation, we are bringing changes to the original function. So when you have this as the original function, the change that we have brought here is therefore y, k, l, and y dash. So let's see how it goes. Here, delta Y shows growth in national income or growth in national output. Now coming to V. V here stands for MP of K or marginal product or marginal productivity of capital. Now, what about W here? W here shows the marginal productivity of labor. Marginal productivity of labor. And here delta L shows growth in labor and delta Y dash. This is what is understood as technical function or technological changes. In that case, let's proceed more about Meade model of economic growth. So, we know that our modified equation now is delta Y is equal to V delta K plus W delta L plus delta Y dash, right? Now we need to find the annual proportional growth rate. So in order to find the annual proportional growth rate, what you have to do is that just take this particular equation and divide both the sides of the equation by y. So this delta y becomes delta y by y. V times delta k becomes v by y times delta k. W delta L becomes W by Y times delta L and delta Y dash becomes delta Y dash divided by Y because we are dividing both the sides of the equation with Y, right? So, when you look at this part, delta Y by Y, it shows the proportional growth that you can find in the net output or your net income. Now, coming to delta Y dash by Y. This is something that deals with the proportional change or growth in technology. Now, let's discuss more about the equations and explanations given by Meade. Now, we need to find the proportional growth rate of capital and labor. Our original equation is here. Our modified equation delta Y divided by Y is equal to V divided by Y times delta K plus W divided by Y times delta L plus delta Y dash divided by Y dash divided by Y. Yes, this is our modified equation. Now I told you that we need to find the proportional growth rate in capital and labor. So in order to find the proportional growth rate in capital and labor, what you have to do is that you need to divide as well as multiply delta K with K and you need to divide and multiply delta L with L. Okay, so this equation becomes much more modified. That is, it becomes delta Y by Y is equal to Vk divided by Y times delta K by K. Again, W plus WL divided by Y times delta L by L plus delta Y dash divided by Y. So you were just modifying this part. Now, in this equation, delta Y by Y, it shows the proportional growth rate in your net national output or net national income. This delta K by K shows growth rate in capital and delta L by L shows growth rate in labor and delta Y dash by Y show growth rate in technology. Now, what about Vk divided by y and Wl divided by y? Vk divided by y and Wl divided by y shows the contribution of both capital and labor here. So Vk divided by y shows contribution of capital, Wl divided by y shows contribution of labor. So it just deals with the marginal productivity aspect of capital and labor respectively. Now our new equation is delta y divided by y is equal to Vk divided by y times delta k divided by k plus Wl divided by y times delta L divided by L plus delta y dash divided by y. Now, in this context, Meade was going for some assumptions. This delta y divided by y part, he considered it as equal to y. And Vk divided by y times delta k divided by k, that is this part. He assumed this as equal to Uk. And Wl divided by y times delta L divided by L. He assumed this is equal to QL. And coming to this part, that is delta y dash by delta y. He assumed this is equal to R. So our new equation would be y is equal to UK plus QL plus R. UK plus QL plus R. Now we proceed with this equation. Now equation is y is equal to UK plus QL plus R. Here we deal with per capita income. Because we need to calculate per capita income. In order to calculate the per capita income, we need to bring the role of population. So what you do is that we will be subtracting labor from both the sides of the equation. We take labor, so we take this equation, we subtract labor from this side of the equation, that becomes y minus L is equal to UK plus QL plus R minus L. So the equation becomes like this. Now, what you do is you can take L as common here and modify the equation again so that it becomes y minus L is equal to UK minus 1 minus Q times L plus R. Now, this y minus L part, it shows the real income per head. Here UK shows capital and R shows this R here shows technology. So you could find that whenever these two factor increases, whenever UK as well as R increases, this increase in both of these will be making real income per head to increase. So whenever there is capital increase in the economy, real income per head would increase. Whenever there is technological progress in the economy, real income per head would increase. But what happens when y minus q times L increases? In such a scenario, what happens is that we are talking about the population growth rate in the economy. And for the very same reason, we could find that this is a factor that depresses the real income per head because population is increasing and income is not able to increase that much. So this will definitely reduce the real income per head. So it's an income depressing factor that you will be having in the economy. Now let's proceed more about Meade model. Now what Meade was doing is that he was introducing savings into his equation. And what he was assuming is that delta K is equal to I. That is change in capital. This is what is identified to be investment in the economy. And also he was assuming saving is equal to investment. That is S is equal to I. So he was making two assumptions. One is delta K is equal to I. Next is S equal to I. Now from this we can equate like this: delta K is equal to I is equal to S, so that you can find that delta K is equal to S, right? So you need to understand that when you write this equation, delta K divided by K, this is growth rate of capital or K. Now he was introducing the element of saving in the economy into his equation so that you have a new equation now by bringing Sy here. So what is it all about Sy? Sy shows the proportion of saving out of income. Now the new equation is delta K divided by K is equal to Sy divided by K. This is a new equation. Now what happens? We have already assumed that Vk divided by y times k delta k by k, this is equal to uk. So this is the already made assumption, right? Now what you do is that instead of delta k, instead of this delta k, we are putting Sy. So we have seen that delta k is equal to Sy. This is something that we have already seen. So instead of delta k, we can put Sy. So the new equation becomes this: uk is equal to vk divided by y times sy divided by k. Because you know that uk is something you're again putting like this. You're again introducing another important element here. uk is equal to vs. So what you have to do is that to bring more related to saving function, you need to put vs in the place of uk. So the new equation would become this: y minus l is equal to uk minus 1 minus q times l plus r. So this would be the new equation here. Now what is it all about? It is all about now critical growth rate in the economy. What is it all about, critical growth rate? Critical growth rate is that particular growth rate where the growth rate of income in the economy is equal to growth rate of capital. That is growth rate of income. Delta y by y is equal to growth rate of capital. Delta k by k. We have already seen that y is equal to uk plus ql plus r, right? And when growth rate of capital is equal to growth rate of income, you can write like this. We can represent delta y by y is equal to y, and delta k by k can be represented as k. So y is equal to k is equal to a. A here means critical growth rate. Critical growth rates. Okay. Now, just reframe this equation. Just take this equation and reframe it by replacing y and k with a. So this equation becomes, instead of y you write a is equal to uk. Instead of k you can write again a. UA plus QL plus R. Now what you have to do? Take this UA to the other side so that you will be getting A minus UA is equal to QL plus R. Now to find A, what you have to do is you can take QL plus R divided by 1 minus U. Send it. Now you get the value of A here. Meade was also explaining his model by going for a graphical representation. So what you can find is that you can take the stroke of machinery along the x-axis and total annual output can be taken along the y-axis. Here you will be getting your technical progress with expansion of output indicated by Q1 and Q2. The production function here. So you could find that when stock of machinery is taken along x-axis and total output is taken along y-axis, when you use OD of machinery in the economy. So OD is the initial machinery usage in the economy. Without technical progress, you can produce AD output in the economy, this much of output. But with technical progress, we can produce this much of output in the economy, that is DD output. Similarly, if this is called F, if this is called G, and if this is called M, with technical progress, you can produce FM level of output when you use OF level of machinery in the economy. But if you're not having technical progress, you can only produce GF level of output with OF level of machinery. So what you are trying to say here is, when you use some kind of technical expansion or technological improvement in the economy, or if there is any kind of modernization or technological improvement in the economy, that will make you to produce more with the available stock of machinery. So this is all about Meade's model of economic growth. I hope you could understand this session. Now, I request you to download Learn Economia app, where you will be getting previous year question papers and answers, free study materials, live as well as recorded classes, and free MCQ based weekly tests. So I'll be providing the link of the same in the description box. You can download it from there. Also, you can join our free Telegram community to have discussions. I'll be providing the link of this too in the description box. That's it. Thank you for watching. I request you to like, share, and subscribe to the channel for more videos. Thanks again.